Question number 1C says, the flow rate of gasoline in gallons per second can also be modeled by the function g, where g of t is equal to t over 500 cosine of t over 120 all squared. And this is for t between 0 and 150. So using this model, find the average rate of flow of gasoline over the time interval from 0 to 150. So first thing we have to do is we have to graph this function. Okay, this function needs to be graphed on the graphing calculator. So the graph should look something like this. When we adjust our windows for the x should be, I've done it to from about 0 to 160, and our y coordinates are going to be not greater than 0.2, so I've made my y max 0.2. So the question asks to find the average rate of flow. Okay, so the average is important here. The average rate of flow would be the average value of this function. Okay, so the average rate of flow. Since this function is already is a rate of flow function, the average rate of flow would be the average value of this function. So we need the average value formula. So the average value formula looks like this. So the average value of, in this case, g of t is going to be equal to the area underneath the g of t graph, or the total gallons, divided by the interval width. So the interval width is going to be 1 over 150 minus 0. That's my interval width. The area underneath the g of t function is going to be the integral. So it's going to be the integral from 0 to 150 of the g of t function. Okay, so what we're going to do then is we need to solve for the area underneath that function, so that when we do the solve for that, we need to use 7, the integral function, and we're going to integrate from 0 to 150, and we should end up with a value of 14.3995. Now that the units of that are gallons, so it's going to look like this. The average value of g of t is going to be 14.3995 gallons over the time interval is going to be 150 seconds. And this is going to give us an average value of 0.09 and rounds to 6, and the units are going to be gallons per second. Okay, so the average value, or the average rate of flow of gasoline, is going to be the average value, and we've got the correct units here, which is 0.096 gallons per second. In part D of question number 1, it says, using the model G defined in part C, find the value of G prime of 140. So we've graphed here G. G prime of 140 is going to be the slope of, or the value of the derivative at 140. So this represents slope. So we're trying to find the slope of that tangent line at t equals 140. Since this is a graphing calculator section, what we're going to do is use the dy by dx function on the calculator. So we're going to go down to our calc menu and use the dy by dx. Using that dy by dx function, the calculator gives us a value of negative 0.0049089. Okay, now we're going to round that to the third decimal, so we're going to end up with this value of 0.005. So G prime of 140 is equal to negative 0.05, and this is going to be gallons per second squared, or the rate of increase of the rate. Okay, so the meaning of this answer is going to be, in the context of this problem, is the rate of increase of the rate function, okay, which is in gallons per second squared. So the meaning could be interpreted through the units that we've given here.